All right, here we are going to be doing 3.7, solving a linear system of equations, day 2. Today we're going to be talking about identifying the number of solutions without graphing, and then also getting into word problems. Here, identify the number of solutions without graphing. If it has the same slope and different y-intercepts, there is no solution because the lines are parallel. If it has the same slope and the same y-intercept, there is infinitely many solutions because the lines are the same. And then if they have different slopes, there is one solution because the lines will have different rates of change. So here, let's look here. Just kind of quickly, again, if I kind of want to go back one page. Graphing on our old one. If you look, if they have different slopes, like this line had a different slope and different slope here, they're always going to have, if they have different slopes, they're only going to meet at one point. If they have the same slope and the same y-intercept, it means it's going to be the same line. So it's going to be infinitely many. And then if they have the same slope but different y-intercepts, one connects or goes through the y-intercept here and one goes through here, that means they're never going to touch their slopes. They both go up 2 and over 3. But every time this one goes up 2, this one goes up 2, and then they go over 3. They'll never intersect. Okay? But you can look at information and decide whether it's going to have one solution, no solution, or infinitely many by figuring out first if they have the same slope. So a system of equations consists of two lines. One line passes through 2, 3, so 2, 3, and 0, 5. And if we notice, this is our y-intercept, so that might give us we might need that information later. The other one goes through 1, 1, and it goes through 0, negative 1. So we know that they have different y-intercepts. So if they have different y-intercepts and they have the same slope, they're going to be parallel, and there will be no solution. But if they have different y-intercepts and different slopes, they will have one solution. So first we have to figure out what the slope is. So we're going to subtract the y's, 3 minus 5 on top, 2 minus 0 on the bottom. So negative 2 over 2 equals a negative 1. And then I'm going to do the same over here. 1 minus a negative 1 and 1 minus 0. So here this becomes 2 and this becomes 1. This is 2. So here our slopes of our two lines are different and they have different y-intercepts. So if you think about it, one has maybe a y-intercept up here and has a slope of negative 1. This one over here has a y-intercept of negative 1 and has a positive slope of 2. So these two lines here are only going to have one solution. Okay, so here let's look again. We're given that they have different y-intercepts. If they have the same slope and different y-intercepts, that means they're going to be parallel lines. So let's check. Like 0, 2, let's do 2 minus 4. Remember the y's on top. And 0 minus 1 gets me negative 2 over a negative 1. And then here I have, which reduces down to 2. And here I have negative 1 minus 1 and 0 minus 1. So again, here I have a negative 2 on top and a 1 on the bottom. Oh, a negative 1, because this is 0 minus 1. So this becomes also, positive 2. And this is a positive 2. So they have different y-intercepts here of 0, 2, and 0, negative 1. So 0, 2 is about here, and the slope is 2. So maybe kind of like that. So up 2 over 1, up 2 over 1. This one has a y-intercept right here, up 2 over 1, up 2 over 1. So maybe this is just a rough sketch so you can see that they have the same y-intercept, but they have the same slant or steepness. So therefore, they're never going to touch. If they have the same the same slope, but different y-intercepts, they are parallel. So there is no solution that they will never intersect. Okay, and then our last one, we see here, we have the same y-intercept. Now, this could mean that I have two lines that intersect at 0, negative 4. But if I have the same y-intercept and the same slope, then it's going to be infinitely many. So you have to double check with the slope and what the slope is. So negative 4 minus a negative 2, 0 minus 1. This becomes negative 4 plus 2 is a negative 2 over a negative 1. This gets me 2. And then here, negative 6 minus a negative 4, negative 1 minus 0. This becomes a negative 2 over a negative 1, which becomes 2. So now, these both have a y-intercept of negative 4, and then they both go up 2 over 1, up 2 over 1. So they both have the same slope. So therefore, it is infinitely many solutions. Oh, I should write many. Because it's going to be the same line. Okay. Here, we have a word problem where we need to set up the equations. So in my word problem, I want to look for keywords that can set up an equation. So let's first read it. Gregory's Motorsports has motorcycles, 2 wheels, and ATVs, 4 wheels in stock. The store has a total of 45 vehicles that together have 130 wheels. So first, write a system of equations that represent the situation. I need 2 equations that you can get out of this. Well, first, I'm going to say motorcycles. Think about the variables, and those are going to be motorcycles and ATVs. At the moment, we don't have one depending on the other, so it could either one could be either. So we're going to say this is going to be our X and this is going to be our Y. So X is going to be the number of motorcycles and Y is going to be the number of ATVs. Well, if you think about looking at this, the store has a total of 45 vehicles. So that means that if I add the number of motorcycles plus the number of ATVs, it's going to equal a total of 45 vehicles. That's going to be my first equation. Then I'm going to look at my other number, 130 wheels. Well, it's going to equal 130, right? Because that's the total. Well, what added together will get that? Well, the number of vehicles on motorcycles added to the number of tires on the ATVs added together. Well, how many wheels does the motorcycle have? Well, it has 2 wheels. So you're going to multiply the number of motorcycles times 2, and you're going to add it to, you're going to multiply the number of ATVs times 4 because it has 4 wheels. Okay, so now first I have 2 equations. I want to solve the system of equations and interpret the solution. Well, I have an equation here that I can write, or I can graph. first I want to label my two axes and my graph. This would be Gregory's motorsport. My X again was motorcycles. Motorcycles. I think I spelled that wrong. It's okay. This is going to be ATVs. I'm going to need to look at how many what I want to go by. Like, do I want to count motorcycles by 100, 200, 300? Probably not, because I only have a total of 45. So that's probably what I want to go off of. Can I count by tens? Well, 10, 20, 30, 40. That would only be using half the graph. So let's go by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45. And that gets me to the total number, and that would be probably a good number. So 5, 10, 15, 20, 25, 30, 35, 40, 45. I'm going to do the same for ATVs. I'm going to count by fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45. All right. I could think about this equation here, and I could graph this using my X and Y intercepts like we did one time, and we don't need to, but I want to just quickly do it, where if you had zero motorcycles, how many ATVs would they have? Well, they would have 45, right? And I could put a dot at 45. Then if I had 0, and when I replace 0, it just kind of goes away. But if I had 0 ATVs, how many motorcycles would I have? Well, I again would have 45. There I can draw my line. But the way we've been doing with solving a system of equations by graphing, we have been getting our equation in slope-intercept form. So I would want to subtract x, then I would have y equals a negative x plus 45, where 45. So I start at that 45 here, and that's when I go down 1 over 1, down 1 over 1, because I have a negative slope. Well, if I go down 1 over 1, down 1 over 1, it's going to get me to this point here. And now I have a point, or I mean a line. And here, I do like to see that I have, these are all points on this line. Okay, so now I want to graph this equation. Here I have, this should be a y. That's one thing we should be careful of when we're writing our x's and our y's, to make sure that they look like x's and y's. So equals 130. I would subtract 2x. Because I'm running out of time, I'm just going to tell you that the equation equals negative 1/2 plus 32.5. So here, this is x. I would start at 32.5, about right here, and I would go down 1 to the right 2. So if I start about here, I would go down 1, right about 2, down 1, go right about 2. No, this is going to go here, down 1, go right about 2. So if I draw this line here, this point right here where they intersect is going to, and my graph is a little wonky, but they're going to intersect at this point, that 25 and 20. That means that for these both to be true, I would have 25 motorcycles and 20 ATVs. And that's interpreting this graph here. 25 motorcycles, because that's my X, and 20 ATVs at this Gregory Motorsport.